Hi, good morning, my dear students. I'm Miss Stephanie Cole. Welcome to my channel, Spark Brilliant Inspire Life. Today we are taking a closer look, not with a microscope, but with a theory. We'll explore how ions behave in the solutions and how the temperature changes their interactions, all leading us to the concept of Ksp. In today's experiment, we are going to investigate the solubility of lead-2 chloride, a salt that doesn't dissolve very much in water. By adjusting the temperature, we actually can calculate how soluble it is, and even determine whether heat is released or absorbed during the dissolving process. So get ready, follow along, and let's explore the dynamic relationship between the temperature and the solubility in simple, clear, and enjoyable way.
After understanding the background of this experiment, we will now move on to the experimental sections. So, how do we actually study this in the lab? The data obtained will then be used to plot graph of Ksp against temperature and log Ksp against 1 over temperature. From this graph, we can determine the relationship between temperature and solubility and also calculate the enthalpy change of the reactions. The apparatus used in this experiment include burette, boiling tube, thermometer, beakers, test tube rack, water bath, redox stand, and clamp. The material required are lead-2 nitrate solutions, sodium chloride solutions. It is important to note that the material and the concentrations used in this experiment are 33 gram per dm cube for lead-2 nitrate and 29.2 gram dm cube for sodium chloride. This is because students must use these concentrations for their calculations and writing the report. There are 5 experiments or trials carried out in these investigations. The first experiment is conducted at room temperature, while the remaining 4 experiments are carried out at different temperatures using a water bath. First, 2 burettes are filled separately with lead-2 nitrate solutions and sodium chloride solutions. Next, 12 cubic centimeter of lead-2 nitrate solution is transferred from burette into a boiling tube. A thermometer is then placed into the boiling tube to monitor the temperature. Sodium chloride solution is then dropwise from the burette into the boiling tube. The solution is observed carefully and the addition is stopped when the first sign of white precipitate appears. At this point, the temperature and the volume of sodium chloride solutions used are recorded in the table 1. The remaining 4 experiments are carried out using a water bath. In each experiment, 12 cubic centimeter of lead-2 nitrate solution is used and a thermometer is placed in the boiling tube to monitor the temperature. Referring to table 1, 7 cubic centimeter of sodium chloride solution is added into the boiling tube. Stir the mixture and allowed to stand for 5 minutes. Then the boiling tube is placed in the hot water bath. The mixture is stirred continuously until all the solid dissolves completely. Next, remove the boiling tube from the water bath and stir gently while cooling. As the solution cools, a white precipitate will appear again. The temperature at which the temperature first reappears is recorded in table 1. It is important to ensure that the recorded temperature is below the temperature of the water bath. Then wash and clean the thermometer. Step 5 to 11 were repeated using different volume of sodium chloride solution as listed in the table 1. To make the calculation easier to understand, I will use selected temperature which are 59, 62, 66 degrees Celsius as examples. Before answering the questions, let's understand the overall requirement of this experiment. We are required to plot 2 graphs to analyze your results. The first graph is Ksp against temperature, while the second graph is log Ksp against 1 over temperature. Now, let's calculate the Ksp for experiment 1 step by step. First, we write the dissociation equations of lead-2 chloride. This is the Ksp expressions. This means that to calculate Ksp, we must first determine the concentrations of lead ion and chloride ion in each experiment. For the first experiment, the concentrations can be calculated based on the material used. From the given informations, the concentrations of lead-2 nitrate and sodium chloride are given in gram per dm cube, so we need to convert them into mole per dm cube using their molar mass. Then, we obtain the concentrations of both solutions in mole per dm cube. Next, we calculate the concentrations after mixing. We use the formula M1V1 equal to M2V2. For experiment 1, volume of sodium chloride used is 4 cm3. We substitute the values to calculate the new concentrations of chloride ions after mixing. Finally, we substitute the value into the Ksp expressions. For experiment 2 to experiment 5, the calculation steps are exactly the same. First, we determine the ion concentrations using the dilution formula. M1V1 is equal to M2V2. After obtaining the concentrations of lead-2 ion and chloride ion, we substitute these values into the Ksp expressions. These are the Ksp value of lead-2 chloride at different temperature obtained from our calculations. We plot a graph of Ksp against temperature. The graph is not a straight line. It should be a smooth upward curve, which indicates that the Ksp value increases as temperature increases. This means that more lead-2 chloride dissolve at higher temperature. At first, find the 50 degrees Celsius mark and place a ruler vertically at the mark and draw a dotted line straight up until it reaches your best fit curve. Mark the point where your vertical line intersects the curve. From the intersect point, draw a horizontal dotted line with your ruler to the left until it meets the vertical y-axis. Read the value on the y-axis where this line hit. Based on the curve, the Ksp value at 50 degrees Celsius is 1.57 times 10 to the power of -3. First, we convert the temperature from degrees Celsius to Kelvin by using the following formula. Next, we calculate 1 over temperature. Then, we calculate the log Ksp using the Ksp value obtained earlier. We plot the graph of log Ksp against 1 over temperature. From the information given, the relationship between the gradient and enthalpy is defined by the provided thermodynamic equations. This is the formula of gradient. To determine the enthalpy change, we need to determine the gradient of the graph first. The gradient is calculated from the graph of log Ksp against 1 over temperature using the coordinates of the first and last data points. From the calculations, the gradient is -122.22. Then rearranging the equations, lastly, the enthalpy change is equal to 23391 joule per mole. Since the gas constant R is in joule per mole per Kelvin, the unit of enthalpy change is joule per mole. So don't forget convert it into kilojoule per mole. This is the standard unit for the final answer.